So we know very well impdp and xpdp, which are the binaries we use to run the export and import with data pump. However, those binaries, they translate the parameters that you provide into DBMS data pump API calls. So what really executes in the backend is the DBMS data pump package in the database. This package, by the way, do further calls in another APIs, like the external table API, if you're using external table access method, DBMS metadata to get the metadata of the objects, and also direct path APIs. Those are just examples of some APIs that are used by the DBMS data pump API. So we all use, again, DBMS data pump through the XPDP and InPDP. Okay, but you can do it straight away. You don't need to go through these binaries. And this is very recommended. So we have some tools that do that, like zero downtime migration, Enterprise Manager, SQL Developer, SQL CL, also ORDS, which is the Oracle REST Data Services. And you can also write your own tool, or you can write your own PL SQL block to do it. It's documented and supported, and we have it in Oracle official documentation. So here are just some ideas of things you could do with DBMS Data Pump API. You could, for example, I see a lot of customers creating the export script in the OS layer with cron tab. So we have a cron tab job that we'll call XPDP. However, you don't need to put it in OS layer. You can put it straight on the database. You can write, instead of a shell script, you can write a PL SQL block and call it, instead of using cron tab, using DBMS scheduler. It's much more simple. You don't need to store your password in text files or call Oracle Wallet. It's already inside the database, so it's much more simple in that sense. Also, you can put dynamically themes on that. Maybe based on the number of schemas, you maybe increase the number of parallels, for example, or get the schema names from a certain table inside your database. So there is a lot of logic you can put there. Also, for example, there is an article I wrote about 7 years ago about how to rename a schema using a loopback database link. This article, it's based on DBMS Data Pump API. So what I do simply is put a database link, point to the database itself, and then I call the DBMS Data Pump API to run an InPDP using this database link, but I use the remap schema. So I change the name of the schema, meaning that I clone the schema. So that's a way for renaming the schema. Also, you could possibly take a snapshot of a given schema during application development, for example. So those are just some ideas. Now let's see how client calls are translated into DBMS data pump calls. So imagine here you have an XPDP. Here is schemas equal to app. The first thing you would do if you are using DBMS data pump API is start with this open procedure. So the open procedure will instantiate a new job. And here H1 is a variable that will have the ID for this execution. It's a handler that will store a unique ID for this call. Now, from this point, everything that we want to change in this export job, we are going to use this H1 variable. So for example, again, the schema is equal to app. So we need to add a filter here. So we use the metadata filter procedure, and we specify that the schema that we are using is just the app schema. Also, we have a dump file. So you use the add file procedure. And here in file type, you'll see that we are adding a file type dump file, meaning we are adding a new dump file to this process. The same applies for the log file, but the file type here for the log file is file type log file. What about parallelism? You can use the set parallel procedure from the DBMS data pump API. So the set parallel here, we put degree equal to 4, the same value we put on the command line. But this is one of the advantages we have when we run this from inside the database. So here in this example, as you can see below, I'm getting the CPU count we have in the server and put in this variable. If you want to do this in the shell script, you would need to connect first on the database, get this variable, and put this in an OS variable, and put this OS variable in the parallel call of your XPDP binary call. So it's much more complex. Here I'm getting straight from the database that I'm already inside. And matrix equal to yes and log file equal to all. we can use the set parameter to define those variables as well. And finally, we start the job. So start job here, I'm passing the handler, and then this will put the job in background. I can optionally call this wait for job that's gonna wait for this job until it finishes and store in this job state variable if it was successful or if it failed. So now I can see what is the status of my job. Imagine now that you already have your script developed using the XPDP command or the InPDP command, and you want to convert it to a DBMS data pump call. You can rewrite it from scratch based on the slides that I just showed you, or you can use this event 146 to get what are the actual calls in DBMS data pump API when you run the command on the binary level. Remember that this system event is a bit resource consuming, so only try it on lab or test environments. So here first, what we do is we enable the SQL trace on this database. Then we finally call the XPDP or InPDP. After we run XPDP or InPDP, we will have in the trace file all the DBMS data pump commands that were called by the binary InPDP in this example. So again, use DBMS data pump. It's a very good API. It's very well documented and everything is in the Oracle docs. We have very good examples there.